Hello guys, we are back now with our third topic of tutorial on decimal fraction. In this section, we will learn about decimal fractions, conversion of decimal fraction into its original fraction, that is also called vulgar fractions, different operations of decimal fraction, and comparison of fractions and recurring decimals. So our first topic is our first thing that we should learn is what are decimal fractions. Simply, the fraction in which denominators are power of 10 is called decimal fractions. Like 1 upon 10, that is equal to 0.1, 1 upon 100, that is equal to 0.01, 7 upon 10, that is equal to 0.0, 0.7, 11 upon 1000, that is equal to 0.011. Now conversion of decimal into vulgar fractions, that is in the original fraction. What basically we have to do, we'll put 1 in the denominator under the decimal point and annex with it as many zeros as the number of digits after the decimal points. Like 0.25, here we can see we have two digits after the decimal, so we will write 25 upon 1, and I'll put 20 here because we are having two digit after the decimal. Now I can take another example also, like 71.678. I can see here I have three digit after the decimal, so I will write it as 71678 upon 1, then 30. Now this is the main topic that I have to learn because variety of questions come from this section only. With the different operations on decimal fraction, we have to learn about addition, subtraction, multiplication, and division. So we do it in the similar way as we do with all the numbers. There is nothing difference. There is a slight difference only with the points, where to put the point, where to put the decimal. Actually, addition will be same as we do in the real life. 5.28 plus 2.11, it will be same. 8 plus 1 is equal to 9, 2 plus 1 is equal to 3, 5 plus 2 is equal to 7, and we'll put the decimal after 2 points. Then we'll subtract the number in the similar way. Now the second one is multiplication of decimal fraction. 5.9632 into 100. What basically I'll do here, I'll multiply these numbers. Now I can see after the decimal I have four digit, and I'm multiplying it with two index of 10. That is, I have 20 here. So in the previous section I have told you to, in the while explaining decimal fraction, how to put decimal. That is, if I'm having 10, that then I will put decimal after one digit, that is before one digit, if I'm starting from right to left. Okay, so we'll just do the reverse of that here in the multiplication section. So I'll put the decimal after two, that is my decimal point will be shifted after the two digit because I'm having 20 here, so the resultant value will be 596.32. Now 0.2 into 0.02 into 0.002. So simply we'll multiply the number plus first 2 into 2 into 2, that is equal to 8. Now I can see in the first one, 0.2, I have one digit after the decimal. Then in the second one I have two digits. Then in third one I have three digits. Total, we can say that 1 plus 2 plus 3, that is equal to 6 digit we have after the decimal. So after a before 8 I'll put 50, so that it becomes 6 digit total after the decimal. Now the division of decimal fractions. So this is very simple. It is as usual only. uh, First what we have to do, 0 point, I'll take example to explain. 0.020, 0.0204 divided by 17. We will simply divide 204 by 17 first. The value is 12. Now I can see I have I have four digit after the decimal in the numerator, so, and I have no decimal in the denominator, so simply I will put decimal before the four digit starting from right to left. In the next example I can see in the numerator and and in the denominator both are having decimal point. So how to solve this question? My question is 0.00066 upon 0.11. Simply I will divide 66 upon 11 first, that is equal to 6. Now I can see I have 5 digit after the decimal in the numerator and 2 digit after the decimal in the denominator. So I will subtract these indices, like 5 minus 2, that is equal to 3. That means in the resultant value, that number of digit that should be after the decimal should be equal to 3. So I have 6 here. I will put two more zeros before 6, and then I'll put decimal. In this way we do the addition, subtraction, multiplication, and division of decimal fractions. Now our next topic is, sorry, Comparisons of fractions. How do we compare? I hope you guys remember my last PPT. In the last video, while I was explaining the HCF and LCM, I had told you to find the LCM of denominator while arranging the numbers, the fraction in the decimal form, sorry, while in the descending form or in the ascending form. So what more we can do with this is, first we will convert the number in the decimal form, then we will arrange them in ascending or descending order. Example, suppose I have to arrange 3 upon 5, 6 upon 7 and 7 upon 9 in descending order. So what I will do, I will first of all convert every fraction in decimal form. So 3 by 5 is equal to 0.6, 6 upon 7 is equal to 0.857, 7 upon 9 is equal to 0.777, and so on. This goes on continuous repetition, that is called recurring, that I'll be explaining you in the next slide. So I can easily see 0.857 is greater than 0.777, which is greater than zero point 0.6. So its equivalent fraction will be in the same order, that is 6 upon 7 is greater than 7 upon 9, which is greater than 3 upon 5. Now the next topic is recurring decimal. If in a decimal fraction a figure or a set of decimal is repeated continuously, then such a number is called recurring decimal. Suppose I'm finding the decimal value of a fraction and I'm getting a continuous repetition of a number. That means that it is a recurring decimal. I'll put a bar above that. I'll not repeat it so many times. I'll write it just one time, and I'll simply put a bar over it. For example, 1 upon 3, that is equal to 0.3333, and so on continuously. It will go on repeating up to the infinity. So I'll just write it like zero point 0.3 and there is a bar above 3. The best example for this is the value of pi, that is 22 upon 7. This is equal to 3.142857. Then again the same number goes on repeating, 142857. So I'll write it as 3.142857 and the bar upon 142857. I have written something in red color here. 3.142857 bar above it is pure recurring decimal, as all the figures are repeated after the decimal. If I'm getting 2, 3 or even more figures after the decimal, different figures, and the same set goes on repeating itself, then this sort of decimal are basically called, in general it is called recurring decimal, but in a specified way I can call it pure recurring decimal. Now suppose I've been given, I'm calling it pure recurring decimal just because every number after the decimal, just starting after the decimal, every number is getting repeated. That is why it is called pure recurring decimal. Now suppose I have some decimal value 0.1733333, and 3 goes on repeating continuously up to infinity. So I can write it as 0.173 and bar above 3. That means I have 1 and 7 also after the decimal, but 1 and 7 is not getting repeated. Only 3 is getting repeated. That means this is called mixed recurring decimal. 0.173 bar above 3 is called the mixed recurring decimal. These are the two types of recurring decimals we have: pure recurring decimal and the mixed recurring decimal. Now I'll proceed to the next topic: converting recurring decimal into fraction. I'll learn for both the types, for pure recurring also and for the mixed recurring also. So for the pure recurring fraction, first of all, let me take an example like 0.53. Suppose I have to write the 0.53 decimal number in the form of its fraction. So what basically I'll do, I'll just write 9 in the denominator. That too, how many times? The number of digits I'm getting after the decimal, I'll write 9 that much times. If it is, of course it is recurring, because we are converting a recurring decimal. So we'll just take the non-repeated value, the single time appearance of the value, and we'll write 9 that times only. For example, 0.53, and there is a bar over 53. That means 53 is getting repeated. The value will be like 0.53535353, and it goes on continuous repetition up to infinity. So I can see that I have two digit here, 5 and 3, that are getting repeated. So I can write it as 53 upon 99. I'll use 9 two times because I have two digit after the decimal that are getting repeated. For example, I can take another example also, 0.067, and I have bar over all the three numbers, 0.67. that is this decimal will be like 0.067 067 067 067 and continuous. So I will take it as 67 upon 3 times 9 because I have 3 digits after the decimal that is getting repeated. Now I have to convert mixed recurring decimal into its fraction. Suppose I'll explain this with the help of example only. Suppose I have the example 0.2273. There is a bar over 73. So what basically I'll do, I will first of all I will sorry. So first of all, I'll subtract that much number of that sorry the same number that are coming before the recurring number from the original number in the numerator. For example, 0.2273 bar is over 73. I will subtract 22 because 22 is not having bar and it is after the decimal. So I will subtract 22 from 2273 and this will be divided by, I am having two digits that are being repeated. So I will write 2 times 999. Sorry, I'll write 2 times 9 and then I'll put 20 because there are two digits that are getting repeated. So I will put two more zero over there. So the value will be like 2273 subtracted by 22 and the whole is divided by 9900. I'll take another example 0.16. I have bar over 6. So I will and I have 1 also after the decimal. It is not having bar. So I will subtract 1 from 16 first of all and the whole will be divided by, I'll write 9 one time because I'm having one recurring decimal. I'll write 9. Then there is one number that is getting repeated. So I'll write 10 over it. So in this way, we convert the recurring decimals into the fractions. So now these are some of the basic formulas that you need to learn because you have been learning this since you were in standard 5, 6 or 7 maybe. So these are the basic formulas that you need to learn. Some of the formulas for finding the factors of some number, and the questions will be based upon these formulas as well as the theories that I have taught you in these sections. So the formulas are like a plus b whole into a minus b. This is very common. This is equal to a square minus b square. Second is a plus b whole square, that is equal to a square plus b square plus twice ab. Third is a minus b whole square, that is equal to a square plus b square minus 2ab. Fourth is a plus b plus c whole square, that is equal to a square plus b square plus c square plus 2 twice whole into ab plus bc plus ca. So I have 8 formulas I have written over here. You need to memorize all the formulas. So in every section, I used to give some of the questions. I used to solve some of the questions of that have been asked earlier in some of the competitive exams. But this time, I'm not going to ask. I'm not going to solve any of the question right now. I'll be solving each and every question in the next video. But I'll be giving you the questions for your purpose, for your homework. You have to solve these questions. I'm giving you 5 questions, variety of questions that have been asked in some of the competitive exams, and you guys need to solve this. You guys just need to pause this video for 2 minutes and copy these questions, and I'll be coming with the solution of these questions in the next video. The questions are here. The first question is here, the second is here, the third is here, and I have also given you 4 options. The fourth is here, the fifth is here. So you guys need to solve these questions. I'll be coming with the solution of these questions in the next video. Soon I'm going to upload the video on the solution of these questions. So thank you so much for watching our video. Do like and subscribe for more videos. You can also follow us on Instagram with the user ID solution for all. Thank you so much.